Section 6.3, volume and surface area. So in this particular lecture video, I'm going to show you how to calculate the volumes, okay, of one of the following six geometric figures. So basically, volume is the measure of space. Sorry, not pace. Volume is the measure of space enclosed by a three-dimensional figure and is measured in cubic units. So whenever you see the word cubic meters, cubic feet, anything with the cubic, that's referring to as finding volume. So generally speaking, okay, this is a very, very general, very, very broad saying here. Volume is always measured by the area of the base times the height of the volume. All right. So the following volume formula is basically go by this general formula. Area of the base times the height. So this is what I'm going to do. I'm going to try to highlight the part that is area of the base. So for a rectangular solid, we call this rectangular solid because its base is a rectangle. Okay, so find the area of the base times the height. So length times width is the area of the base, then times the height. That will give me the volume for the rectangular solid. All right, a cube. Okay, so when you see the word cubic or the word cube, you're thinking about volume. You also think about an actual cube. Okay, you also think about an actual cube. And the reason I mention that is because when we talk about conversions of capacity and volume, we will begin to see the units with a cube on it. Okay, like cubic feet, cubic inch, all that is referring to volume, and also referring to you have a cube. So to find the volume of a cube, okay, basically my base is a square. For being a cube, all sides are the same, so the height of the cube is also the same as all the other side. So normally when you find the volume of the cube, it will be side times side times side, or side cubed. The first two, side times side, will give you the area of the base. Okay, it will give you the area of the base. Right, sphere. Sphere is always going to be, the volume for sphere is always going to be 4/3 times pi times radius to the cube. All right, that doesn't change. This is the set formula. Right circular cylinder. All right, so when it comes to cylinder, we are using circle for base, and this is something we got to also notice is the area of the base. Okay, the name of all these geometric solid is based on the shape of the base. So we call this a rectangular solid because its base is a rectangle. So circular cylinder is using circle for base, and we also need to know, okay, how many bases that we have as well. Okay, normally for cube, geometric solid, cylinder, it only consists of two bases. One on top, one in the bottom. All right, so this is called the circular cylinder because I'm using circle for base. The word right is referring to the height and the base are perpendicular. So to find the volume of a circular cylinder, that will be area of the base, which is pi r squared, times the height. All right. A circular cone. All right, cone is actually where cone and pyramid is where all sides come to a single point up top called the apex. Okay, it's called the apex. So cone and pyramid only has one base. All right, not like the geometric solid that I mentioned above. So the word right is referring to the height, the actual height, and the base is always perpendicular. So for cones and pyramids, all right, there's always going to be 1/3 at the front of the formula. right? So the volume of a cone, of a circular cone, is 1/3 times area of the circle base times the height. For a square pyramid, that will be 1/3 times area of the base, which is size squared, then times the height. Okay, so let's try some example here. Nothing hard. So this is a cube because all sides are the same. So to find the volume, that would just simply side times side times side times side, or side cubed, which would be 11 times 11 times 11, or 11 to the third power. Either way, 11 to the third power. So my answer, 1331. All right, cubic meter. All right, so this is a rectangular solid because my base is a rectangle. So to find the volume, that will be length times the width, area of the base, then times the height. So that will be 12 times 5 times 8. 480 cubic feet. Now, this picture here does not look like any one of those we just saw. All right, but this is actually considered as a solid. All right, what is the base? Okay, I need your imagination a little bit. This rectangle, this face is facing us. This part down here is actually facing the bottom. So there's another side actually facing away from us. So I got 3 sides that are rectangle. It cannot be the base because when it comes to a geometric solid, we only can have 2 bases. Okay, cannot have more than 2 bases. So this problem is actually is what we so-called a triangular prism. It's actually using this triangle as for base. If you ever have to take Math 168, we will actually use the word prism rather than using the word solid. Okay, this is actually considered a triangular prism because I'm using triangle for base. So that means my volume, by being area of the base times the height, to find the area of a triangle, that will be half times base times height, just like we mentioned in the in 6.2. And then times the height of my prism or solid. So this is going to be 0.5 times the base here, okay, got to be 14, times the height up and down must be this 24. All right, times, okay, the point at this arrow, times the actual height of the entire prism or solid. So if we will actually put my place my triangle base facing downward, okay, if we will actually lift this up, then the actual height is actually the 27. Okay, how tall is this prism or this solid is. So just kind of lift it up, make sure the triangle face facing downward. Okay, the other triangle face facing upward, so that will tell me my entire height, okay, is going to be 27. So let's type it in, 0.5 times 14 times 24, that gave me area of the base, then times the height, 27, 45, 36. So my volume, 4,536 cubic centimeter. All right. Find the volume of the figure below. So this is the right circular cylinder. So the volume, pi r squared, give me the area of the base, then times the height. So 3.14 times radius. Okay, so whenever we deal with circle, you got to know what it's giving me for the circle base. So the 12 from the center to any point on the circle, that must be my radius. So that will be 3.14 times 12 squared, then times the height up and down must be that 9 feet right there. round to the nearest hundredth. So let's see, 3.14 times 12 raised to the second power times 9. So that'll be 4069.44. All right, cubic feet. All right, that's all it is. Let's try some word problem here. A pool in the shape of a right circular cylinder is 4 feet tall, has a diameter of 22 feet. What is the volume of the pool? So this is the same formula as earlier. So I'm having myself a right circular cylinder. So it's going to be pi r squared, area of the base times the height. So the problem told me the diameter is 22 feet, but the formula called for radius. So we know radius is half a diameter, so that must be 11. So this pool, 3.14 times the radius 11 squared times the height of the pool, which is 4 feet tall. So let's see what the volume is. 3.14 times 11 to the second power times 4, which is 151976. 1519.76 cubic feet. Okay, that's how much volume or how much space is inside the pool. You are building a house with a concrete foundation, okay, that needs to be 50 feet long, 37 feet wide. So by looking at the dimension, I know my base is a rectangle. It needs to be 3 feet deep. How many cubic feet? See the word cubic? That means finding the volume of the concrete would need it for the foundation. So by looking at the dimension, I know this is going to be a rectangular solid. So the volume must be length times width, which is area of the base, then times the height. So real easy. 50 times 37 times 3 feet deep. So that gives me 5,150 cubic feet worth of volume. All right. Let's see. You need a fish tank that can hold 7,020 cubic inch of water. So if my tank can hold 7,020 cubic inches of water, so that means my volume. So this 7,020 must be my volume already. If the tank is to be 30 inch long and 18 inch wide, how tall would it be? So basically, by looking at the dimension, I got myself another rectangular solid here. But this problem gave me the volume already. So the only thing missing would be the height. So I'm basically going to use this formula to help me to find the height, solving for h. So 7,020 is my volume, which is come from the length times the width and then times the height. So now the only variable missing is h, so I can actually solve for h real quick by writing out my formula. Now this whole right hand side is only one term, okay? This whole right hand side is only one term. So let's see what's 30 times 18 times h. 540h. So 540h is set equal to 7,020. So to find the height, we'll divide both sides by the coefficient 540. So my h, my height, 7,020 divided by 540. My height is 13 inches. Okay, that would be my answer. All right, so in this lecture video, we quickly go through a few examples on how to find the volume, okay, of our basic three-dimensional geometric solid. Okay, so in math, if you ever had to take Math 168 after this class, if you ever have to take that class, we will talk more about other formulas as well. All right, that will conclude this lecture video on the volume of one of the following 6 geometric figures. Thank you for watching.